Hello, it's time for video number 78. This is about factoring by grouping. We're really getting down to the end of factoring. We got a little bit more to learn, and we should be able to factor any non-monic or monic polynomial. Factoring by grouping is going to help us factor non-monics, trinomials whose leading coefficient is not 1. All right, but I'm getting ahead of myself a little bit. First, I want to start with a little review. Factoring by grouping depends on greatest common factor and being good at factoring out the greatest common factor. So it's never going to be too bad, though. These are kind of very typical examples of what we need to do. So in all these 6 problems, we want to factor out the greatest common factor. So the first step is to find the greatest common factor. Start with the numbers. The largest number that goes into 6 and 9 is 3. And then this has 2 factors of x. This has 1. So both terms have at least one factor of x. So the greatest common factor is 3x. I'm going to write that times whatever we need to multiply by to get our original expression back. Okay, so this is called kind of pulling out 3x. We're dividing both of these by 3x. Okay, so in order to get 6x squared, I would need a 2x here. 3 times 2 is 6, x times x is x squared. Then 3x times what is 9x? Well, I need a 3 here, and actually we're done. 3x times the quantity, 2x plus 3, is equal to 6x squared plus 9. All right, this is going to go a little faster now. So the greatest common factor of 14 and 7 is 7. They both have at least one x, so the GCF is 7x. Okay, 7 times 2 is 14. We have 1x, but we need 2. So we're going to multiply by 2x. Okay, then what? Well, since this is minus, this is going to be minus. 7 times 1 is 7, and we already have an x, so we don't need another one. 7x times 2x is 14x squared. 7x times minus 1 is minus 7x. All right, greatest common factor between 7 and 16 is 1. They have an x in common, so the GCF is just x. We're going to need a 7x here, and we need a 16 there to make 16x and 7x squared. Okay, these are even shorter down here. Greatest common factor of 4 and 14 is 2. That's the largest number they can be divided by. This one has one factor of x, but this has no factors of x, so they don't have any x's in common. The GCF is just 2. So I need 2x here, so that 2 times 2x is 4x, and I need a plus 7. Greatest common factor here is 3. So 3 times what will give me that? 3 times x. Since that's minus, this is going to be minus. And 3 times 2 is 6, so this should be minus 2. All right, last one. 5 is the greatest common factor. So we have 5 times x, and then 5 times 4 is 20, so this is going to be minus 4. All right, that's the kind of factoring we're going to need to do factoring by grouping. Okay, I just want to take a look at something here. We multiplied using the box method. We've multiplied using everything with everything. They're all kind of equivalent. This is using strictly the distributive property. And I want to show you that as we go forward and use the distributive property, we end up with our unfactored trinomial. The process that we're learning is how to go backwards and end up with a product. So when we're multiplying out, the way we're doing it here is we're distributing this whole second expression that's in the parentheses. We're going to do all of that times 3x and all of that times 10. Okay, so this is kind of backwards factoring. This is when we're back to multiplying, which we did earlier. So 3x times 2x minus 6 is what we have right here. And 2x minus 6 times 10 is what we have right there. Okay, now if we were going to continue multiplying, we have 2 distributing problems here. We got to do 3x times 2x and 3x times minus 6. That's what's right here. And we got to distribute the 10. That's what's right there. And if we combine the like terms, we end up with 2x. So I'm just looking at, for the standpoint of multiplication, these are kind of the expressions we get if we use the distributive property each way. Now, what we're learning is to go backwards. We're going to learn how to split up this term into 2 terms. Okay, then we're going to factor out the greatest common factor in each half here. In the 6x squared minus 18x and the 20x minus 60. And then we're going to learn how to write it as fully factored. Once we pull 2x minus 6 out of both, we're left with this. So multiplication is kind of the way we go down. Factoring by grouping is the way we kind of go back. Okay, so today we're going to start with expressions like this. They're already kind of split up. And we're going to go to this middle step and then back to this as in factored form. All right, so multiplying out and factoring are opposite kind of processes. All right. Okay, well, let's get busy and do some examples. We're going to do these these four examples, and we'll be finished. So we're just doing factoring by grouping. The external is kind of already split up for us. So we're going to group these two terms and factor out the greatest common factor, and we're going to group these two terms and do the same thing. So the greatest common factor here is 2x, and that would be times x plus 6 to make that work. Then the greatest common factor in between these two is 5, so we have 5, and that would be times x plus 6. Now, both these terms contain a factor of x plus 6. That's why this works. We can factor that out. This is x plus 6 times 2x, and then x plus 6 times 5. So if I pull out the x plus 6, I'm left with 2x plus 5, and all of that's times x plus 6. So here we are in factored form, and if I distributed the x plus 6, we'll be back to here. Okay, this takes a little getting used to, but I think after you practice it a little bit, it'll become very automatic, and that's what we need. When this comes automatic, we can kind of move forward to the last part of factoring. The greatest common factor here is 6x, and this is times x minus 2, plus, I know this needs to be something times x minus 2. 12 goes into both those numbers, and it's 12 times x minus 2. So that's a little hint on the second part. The quantity in parentheses has to be the same as the first one, or this just doesn't work. Okay, I'm going to factor out the x minus 2. So this is 6x plus 12, all times x minus 2. We just pulled this out to here. All right, we factored it out. All right, two more and we're done. First two, greatest common factor is 4x. That'd be times 2x minus 1, plus greatest common factor here is 11, and that's times 2x minus 1. All right, that's kind of the hard part. Now we're just pulling out 2x minus 1. After we pull it out, we're left with 4x plus 11. So all of that is times 2x minus 1. All right, last one. Greatest common factor is 4x. So 4x times x plus 2. I know I need an x plus 2 here. The question is, what goes here? What do I multiply that by to get this? Well, it looks like we need a minus 14. So minus 14 times x is minus 14x. Minus 14 times 2 is negative 28. That works. So here I really relied on that clue that x plus 2 needs to be there. And now factor out x plus 2. This is 4x minus 14 times x plus 2. Done. Okay, I have a short journal assignment for you. These first two, just factor out the greatest common factor, like our first set of examples. And then these last two, do factor by grouping the factor of the expressions. So remember, group it into two groups. Factor out the GCF of that group and the GCF of that group to get started. Same thing here. Factor out the GCF of that part and then the GCF of that part. All right, good luck.